In this demo, we will transfer data from a CSV file to the statistical program R, and we will perform some basic statistical analysis on the data. So the first ingredient is a comma-separated values file that we obtained in our previous demo. Next, we need to open the R program. And so we have the file and the program. Now, to import the file into R, we need to use the command x equal read CSV, as in read comma separated values. But in order to complete this action, we need to actually know the full path name of the comma separated values file. So we called the properties. We brought up the properties by right-clicking on the file, right? Here it was, and we have the properties of the file. The main component of the path of the file is the directory or the folder in which it resides, and that window calls the location of the file. Okay, we will need to copy and paste that into R. We also need the file name component of the file, and so we copy that and we append after a backslash. So here is the complete path. However, R doesn't understand the Windows convention about separating files by backslashes. So what I'm gonna do is replace backslashes with slashes, which separate the file components correctly in a way that R understands. So we prepared the file path. Now I just hit enter and the data momentarily should be in R. To convince myself that it's really there, I say X and it prints the data. Okay, so I have R, and I have the data in it. Now, a thing worth noting is that the data is in the variable X, and it's in the form of a data frame, which I can detect by saying class X. A data frame is a way to combine categorical data with numerical data in one sort of big table. The first sequence of numbers is just numbers, the rows of the data. In order to process the data, I need to know something about the addressing of the data by R in data frames. So the basic way is, for instance, how do I extract the entry at the intersection of the 51st row and in the first column, X51 1. Well, that's Wyoming. It's in the first column, the categorical column of the state names, and it's in the row number 51. Similarly, I can extract the value associated with Wyoming, the damage from tornadoes in this case in Wyoming, in millions of dollars, from the right column. What if I want the entire column of numerical data? Well, I actually address it in the following way. I skip the first index, the row index, and just leave the second index. And since I want to save it in a new variable or in a new vector, then I say y equals x open square bracket comma 2 close square bracket. Now the data is in the variable, and I can compute, for instance, the standard deviation of y, the 5 numbers summary statistics. That means the minimum, the first quartile, median, mean, and third quartile, and the maximum. I can draw a histogram. I can draw a pie chart. And I can draw a histogram with a different number of classes. So for instance, if I want to summarize the data more than before, I can name the number of classes to be 5. This ends the demonstration.